Welcome to our exploration of the potential for life on Mars and Earth's relationship with space events. Mars, our red neighbor, has long captivated our imagination. Could it have once harbored life? And if so, what happened? Fasten your seatbelts as we embark on a cosmic adventure. We humans tend to think we're the center of the universe, but what if life exists beyond our pale blue dot? Mars, with its rusty red surface, has long been a prime suspect. Mars is in the habitable zone, just right for liquid water, a key ingredient for life as we know it. The universe is vast and mysterious. It's entirely possible that life exists out there in forms we haven't even begun to imagine. What if life on Earth didn't start here? What if, billions of years ago, Mars was a vibrant, watery world teeming with microscopic life? And what if pieces of Mars carrying these tiny life forms crash-landed on Earth? It's a hypothesis called panspermia. If true, we might all be Martians, descendants of those early Martian microbes. It would mean that life as we know it originated from another planet, changing our perspective on our place in the cosmos. To understand how planets form, we need to rewind the cosmic clock about 4.6 billion years. Imagine a vast cloud of gas and dust, a nebula floating in space. Gravity pulled the particles in the nebula towards each other. The cloud collapsed in on itself, spinning faster and faster, eventually becoming so dense and hot that nuclear fusion ignited in its core. Boom! Our sun was born, bathing the surrounding disk of leftover gas and dust in its light and heat. Our newborn sun was a hothead, blasting out intense radiation. The planets, including Mars and Earth, were cooling down from their initial molten state. Closer to the sun, it was too hot for lighter elements like hydrogen and helium to stick around. They were blown away by the solar wind, leaving behind heavier elements that coalesced into rocky planets. That's how we got Mercury, Venus, Earth, and Mars. Farther out, beyond the frost line, it was cold enough for lighter elements to remain, forming the gas giants. Mars was in a prime location, not too hot, not too cold. Evidence suggests that billions of years ago, Mars was a much warmer, wetter place, with rivers, lakes, and even vast oceans. We see the scars of this watery past etched on the Martian landscape. Dry riverbeds, ancient lake basins, and minerals that only form in the presence of water all point to a time when Mars was very different. But what happened to all that water? Where there's water, there's a good chance of life. On early Mars, conditions might have been just right for microscopic organisms to emerge. These Martian microbes might have been anaerobic, getting their energy from chemical reactions in the water. Life is incredibly resilient, finding a way to exist even in the harshest environments, but their time in the sun was about to run out. Around 4.5 billion years ago, our solar system was a chaotic place. A Mars-sized object slammed into a young Earth with incredible force. The impact ripped a chunk out of Earth, sending molten rock and debris into space. This debris eventually coalesced to form our moon. The collision sent shock waves throughout the solar system, disrupting the orbits of planets, including Mars. It was a cosmic shake-up of epic proportions. The formation of our moon was a defining moment for Earth. The moon's gravity played a crucial role in stabilizing our planet's rotation, preventing wild swings in its axis tilt. This stability is essential for life, providing relatively stable seasons. Thanks to our moon, Earth has relatively stable seasons, which is pretty awesome. It's a reminder of the delicate balance that sustains life on Earth. While Earth was enjoying stability, Mars was going through dramatic changes. Volcanic activity was rampant, spewing molten rock, ash, and gases into the atmosphere. Olympus Mons, the largest volcano in our solar system, is 3 times taller than Mount Everest. These massive volcanoes released gases that helped to replenish Mars's atmosphere, creating a temporary greenhouse effect. Some scientists believe these eruptions might have even melted subsurface ice, creating temporary pockets of liquid water. Mars wasn't destined to hold on to its water or its warmth. Its smaller size and weaker gravitational pull meant it slowly lost its atmosphere to space. Without a thick atmosphere to trap heat, Mars grew colder, its oceans and lakes froze solid. its once possibly habitable environment transformed into the frigid desert we see today. While Mars was freezing over, Earth was becoming increasingly hospitable to life. The moon's gravitational pull created tides, playing a vital role in the early evolution of life. Earth's distance from the sun provided the perfect amount of energy, allowing liquid water to exist on its surface. Photosynthetic organisms pumped oxygen into the atmosphere, paving the way for the evolution of oxygen-breathing creatures like us. As life on Earth flourished, it faced a new challenge: the sun's harmful ultraviolet radiation. Over millions of years, a protective layer of ozone formed in Earth's upper atmosphere. This ozone layer acts like a giant sunscreen, absorbing most of the sun's harmful UV rays. Without the ozone layer, life on Earth would be confined to the deep oceans or underground. Mars and Earth started out remarkably similar, both with the potential for life, but their fates diverged dramatically. Mars became a barren wasteland, while Earth became a vibrant oasis. Imagine if we could rewind the cosmic clock and change just a few variables. Could Mars have become a second Earth? It's a question that continues to fascinate scientists. Fast forward to a time when dinosaurs roamed the Earth. Their reign came to an abrupt end 66 million years ago. An asteroid about 6 miles wide slammed into Earth near the Yucatan Peninsula. The impact triggered tsunamis, earthquakes, and wildfires, releasing billions of tons of dust and debris into the atmosphere. The dinosaurs couldn't survive this apocalyptic event. Their extinction paved the way for the rise of mammals and eventually for the emergence of our own species. In the aftermath of the dinosaur extinction, mammals were given a chance to thrive. They diversified, evolving into a wide range of shapes and sizes. Among these mammals, a lineage eventually led to us, Homo sapiens. Our intelligence and ability to reason come with a responsibility to protect the planet that has nurtured us. Here we are, billions of years after the Earth formed, living on a planet that teems with life. We've got liquid water, a breathable atmosphere, a protective ozone layer, and a stable climate. But this delicate balance is not indestructible. We are now facing new challenges that could jeopardize the future of life on Earth. The universe is beautiful but indifferent to our fate. The same cosmic forces that created our planet could also lead to our demise. We're facing challenges of our own making, like climate change and nuclear war. Climate change is already altering our planet's climate, leading to more extreme weather events. It's a sobering thought, but one that we need to confront. Even in the face of existential threats, there's reason for hope. Life is incredibly resilient, constantly adapting and evolving to survive. If humans were to go extinct, life on Earth would go on. New species would evolve to fill the ecological niches we left behind. Earth is not a permanent fixture in the cosmos. In about 5 billion years, the sun will run out of fuel and expand into a red giant. Our planet will be reduced to a charred cinder consumed by the star that gave it life. It's a sobering thought, but it puts our existence into perspective. We are but a blip on the cosmic timeline. Earth is a precious and fragile oasis in the vastness of space. Life is tenacious, finding a way to exist even in the most extreme environments. The universe is full of wonders, but for now, Earth is the only home we know. It's up to us to protect it and preserve its delicate balance for future generations. Thank you for joining us on this journey through the cosmos. We've explored the possibility of ancient oceans on Mars and the resilience of life itself. What other secrets does the universe hold? The possibilities are as vast as the cosmos itself. If you think that our content is helpful and informative, then make sure to smash the like button and subscribe for more interesting facts in future.